All right, so GitLab. Why GitLab? We want CI/CD to be there, right? We want our pipeline to be, or our source code to be built automatically so that we don't have to build it locally and then publish it and then deploy it. So we don't want all that. We discussed CI/CD in the very first session, I think, last week. And this is the flow of information here. So you are a developer. From developer, it goes to build process, then some test happens, then some scanning happens, then we build Docker, and then Docker, whatever we built gets scanned as well. Then we push Docker, and then we deploy, right? But we will not be able to do everything today. I will introduce this platform called as GitLab, which is very similar to how Jenkins work. If you have already seen Jenkins, okay, anyone here who has never seen Jenkins at all, ever? Okay, everyone has seen or worked on Jenkins before?
No, Akash, we have not
Yes, sir.
done Jenkins. We have not seen Jenkins.
Okay, I have not seen, huh? Okay, fine. I'm just checking if I can show you. I did have a local installation of Jenkins somewhere, or root. I forgot the password. I have it in local, but I forgot the password. What I kept here. Sorry, so I could not show you that here. But I will learn something better, huh? So GitLab is a bit. I find it better. I find it better in Jenkins because it has a lot of things out of the box, and you don't have to rely on many other things. Like even the installation is something which you don't have to do. What I'm using is the GitLab cloud version. It's an open platform which I can use as long as my repositories are public. Very similar to if you have seen GitHub. In GitHub, there is something called as GitHub Actions, and there also you can build your CI/CD pipeline. But let's start with GitLab quickly. Let me introduce you these pipelines. This platform. So first thing first, you need to launch gitlab.com, and then you have to log in. Sorry, you have to sign up first, create username, password, and all, and then you have to log in, of course. Once you do that, then for you it will be blank project. Okay, for me, I have already created certain projects here, so it's not a blank project for me. Now GitLab is divided into, you can categorize into multiple groups, right? So you can create a group, then you can create another group, and then you can create another group. Any number of groups you can create, and then you can create a project. A project represents a Git repository. Okay. So what I've done is I've created a group here called as Akash group. You would see a button called as new group. Whenever you want to create a group, you just simply say new group, and then inside that I've created this Akash lab, and within it I have created this something called as my experiments, another subgroup. This is also another subgroup I created inside this Akash lab. And if I go inside this, these are my projects. And a project represents a Git repository. Okay, so I have created these two projects here, which represents my Git repository. Now, where to start from? So now I already have it, but you don't have it. So what I do is, if you remember yesterday, this is what I was playing with, right? If you remember, I was playing with open my static site. So I was playing around with this. I created some Docker file for this, and then I did Docker build, and then I did Docker run, and then Docker push. And when I pushed it, it went inside my Docker Hub repository, right? So I Docker Hub. Okay, so come on, it's docker.com, Docker Hub. and I published it in my Docker repository. I don't know why it's coming here again. Never mind. If I sign it, it will go to the actual one. So you see, I have published my image, my static site 360.743 here, and then anyone, because it's public, then anyone can do a Docker pull on this image and can run on the local. But I did all of this manually, right? I did all of this manually. So what I did, I came here, I ran Docker build and then Docker Docker tagging. Then I did, and then I checked it locally whether it's working. So I said Docker run, and then I did Docker push, and then it was published. But that's not the right way, right? Because we don't want these things to be done locally on our on developers machine. However, you can do it, but we need to have a proper CI/CD pipeline for this. Now, what I'm showing you right now, or today, what we'll understand is the CI aspects of it, continuous integration part. So we will be doing continuous integration, wherein the moment a developer commits a code, the pipeline should trigger and do all the checks, stage after stage. There are different stages are involved here. A stage simply means a task, something which is to be done in that pipeline. That's called a stage. So let me go back again just to give a glimpse about it. So all of these are nothing but stages. So my pipeline is things from here, developer's machine, goes directly to production. So this is my complete CI/CD pipeline, but I am right now building it slowly. So I will go stage by stage. So my first stage here is build, and source code is means I have to first place my source code into the repository, of course, that I have to do. But then I have to build it, and then I have to do a Docker build so that Docker build, my application can be containerized, and then I can do a Docker push so that my image or container gets published to a registry. That's what we're going to do with GitLab today. So that's the reason why GitLab is being used. And if you have used Jenkins before, if you haven't, then it's fine. I'll explain the basics again. But if you have used it, it's very similar to what you have seen in Jenkins, where you have stages, and then you have stage, and inside stage you have jobs. It's very, very similar to that. But few structural differences, of course, because they are two different tools. So first and foremost, what you do is you click on new project. Then you can select do few things here and there, but I would ask you to start with a blank project. And the blank project, you give it a name. So I am giving it a name, something like this. I've appended a Z in the front. This gives me a clue that I have to delete this later because I have already done this. So I simply say my static site. Okay. And you can keep it public or private. Public has more features available. If you try to make things in private, few features GitLab are not available. So make it public. You have nothing to hide here. Okay. Then there are two options here: initialize the repository with a README, or initial or enable static application security test or SAST. For now, you can keep it enabled, keep it disabled, doesn't matter. I am keeping this enabled for now. But that's not what you're going to look at today, but you can keep it as a check here. Then you can click on create project. And the moment you do that, what you see automatically because since you have clicked on that checkbox, you see a file called as gitlab-ci.yaml file. This is very, very similar to your Jenkins file. When you are creating a pipeline in Jenkins, you have to have a file called a Jenkins file. So in GitLab, that feature it looks like or is configured in the format of a YAML file. So we say gitlab-ci.yaml. What is .yaml? .yaml is a configuration file. It's been adopted by all the modern tools. This is where you define your configuration. So it's a configuration file. YAML files are configuration files, similar to JSON, similar to TOML. There's a file called as TOML. The different file syntaxes are available. XML, if you've seen XML, they're all file syntax or file types where you represent data, or you can configure things. And all the modern tools currently use YAML files. Even if you have even if you have seen Kubernetes, that also uses YAML file. Even Docker Compose file is a YAML file. So this is a YAML file. It has a specific structure. I asked you guys to go through YAMLs before. I've provided some links, and I think in the class also I've asked you to go through what YAML is, how YAML works, etc. But there's a structure here. Plainly speaking, there's a structure that I'm going to explain. So what I do is I will now edit the file in a web IDE so that I don't have to do it from my local. However, that also you can do. Right now, I'm doing it from a web IDE, which is also quite nice feature of GitLab. So what do we have here basically? How we do things here, right? So let me remove the comments. First thing you mentioned is stages. And when you see a hyphen symbol here in YAML, that means a list. So I'm saying stages is a key, and under this I have multiple stages. So I'm saying build, test, then I'm saying deploy. Right? Let's say that you have these three basic stages: build, test, and deploy. For now, you can ignore these two things. For now, just ignore this. Ignore the below snippets. Okay. So first you have to define stages, right? Once you define the stages, then you have to define the jobs, right? So first thing is define the stages. Second thing is Second thing is define the jobs. Okay. And I've defined the stages. Stages can have any name, right? So I have build, test, deploy. I've defined 3 stages. And now I'm going to define the jobs. So jobs can have also any name. So I can say build my static site. That's my job name. And then I have to uh, put a tag here called as stage, and then I have to link it with a specific stage. Okay. Then I will simply say script, what I want to do inside, and let's say I'm simply saying echo hello, something like that, or hello Akash. Okay, as simple as that. Now let me again try to declutter this. You have stages, then under stages you have three stages defined, but they will not do anything by its own. So you need to attach jobs to your stages, right? Jobs are the things which actually do the thing, not the stages. Stages are how you maintain the sequence. What is to be done first, what is done to be second, what is done to be third, that is defined by stages. So build will be run first, then test will be run second, and then deploy will be run next. But as it doesn't have any job, nothing will happen. So you have to define a job and then have to link it with the right stage. So I'm saying this is the name of my job, and this is the stage name as build. So when build stage is being executed, this job will be triggered automatically. And if let's say I have one more job, so I have this job and I say I have one more job, site 1, then both of them, if you see, the stage is marked as build for both the jobs, and that means the both job will execute parallelly the moment build stage is triggered. Okay. Let me run this so that gives you more clarity. Okay, so I am saying 1 here and I am saying 2 here. I am saying job build job 2, and here I'm saying build job 1, and I'm saying commit this to main. So this will go and commit to main. And if I go back now, I have this menu here. So what I'm doing right now is under repository. So if I go to repository, this is where I'm doing things. I've just modified gitlab.yaml file. I put these two things. This is my web IDE, so I'm modifying things from here, but eventually it's going to come and come and display here. And sorry, and this is where my source code is present. But then if I go to build and if I click on pipelines, I would see something being triggered there, which is this, which just got triggered because I have committed something. The moment I commit something, it automatically triggers. And that's the advantage of having a CI/CD pipeline. And that's exactly what we want. The moment developer commits the code, the pipeline should trigger automatically. Now, what is being executed here? Let's see that. So this is your pipeline. Pipeline has a specific ID. This is the ID of the pipeline. Who triggered it? I triggered it. And then it is showing stages. So when I click on it, it's saying it executed 2 jobs here. So site 1, build my static site 1, build my static site 2. So the stage, which was the build stage, had 2 separate jobs which got executed. And if I go and click here, it shows me the log of what happened inside. Now there are a lot happening inside. We'll go to it one by one. But if you see, I have echoed a hello Akash build job 1 here, and that's got printed, something like this. And the same thing goes with if I go back and I click on build my static site 2, I see hello Akash build job 2. So I have 2 jobs here, one job which got executed, which is this one, and second is actually this one. How did it happen? Let's go back again. So I have build stage, I have test stage, I have deploy stage. And when I said build, and then with the build, I have 2 jobs linked. And the moment I do that, the moment the build job is triggered, these jobs will also get executed. Okay, let me compare this with Jenkins. Okay, what happens in Jenkins? To do that, let me open a Jenkins file, syntax, so that it gives more clarity what really is happening here. So this is how a Jenkins file look like, right? So we have pipeline stages, then you have stage build. Inside stage build, you have steps. Steps are nothing but actually what we call job in GitLab, right? So steps are the thing which actually executes. So we have stage, and then you have steps. Then you have, sorry, you have build stage, then you have a step, then you have test stage, you have a step, then you have a deploy stage, then you have a test. Sorry, you have a step. But instead of representing this information like this here, you represent it in bit different ways. So here you simply first define what are the stages you have. You say build, I have 3 stages, build, test, and deploy. I have 3 stages, build, test, and deploy. And I execute, and this will be executed in sequence, very similar to this. So first this will be executed, then this will be executed, and then this will be executed. In the same way, here the same pattern is employed. So you have build, test, and deploy executed first in the sequence, and then whatever is linked to that build or that stage are defined later. So instead of defining this like this, which happens in Jenkins. In Jenkins, you define the stage and then the stage name, and then you define the job. We don't do that like this here. We keep it separate. So we say in GitLab, these are the 3 stages, and then you define the job separately, and then you link the job with which build you want to link it to. Okay, am I making any sense, or it's a bit confusing? Because this is the first thing in GitLab. You need to understand how GitLab-ci.yaml file looks and how it works. All clear?
Yes, sir.
Yes, sir.
Okay, fine. Anyway, it's not that difficult a thing. Just in case if you have a doubt, please do ask. Huh? Interrupt in between and ask. Okay, so we have done with the basic thing of how GitLab YAML file is to be created. Now let's go one step ahead. Now, what we were doing yesterday, right? We had this code here, which had three things: index.html. Imagine this is my source code, which I want to build. Docker file, again, a file to build my Docker image, and then gitlab-ci.yaml file I today added, okay, which has nothing at the moment. But these are the two files which I needed um, to build my software and containerize it and do all the Docker related things there. Fine. Now we'll do the same thing, but this time we'll try to do this with the CI/CD pipeline. Okay. Now let me go ahead and add this file from my web IDE. So I am just using the online editor. I'm going ahead and saying index.html. Okay, and then I will go and add this file here, and I'll keep it simple. I'll leave it as it is. How are you? This is a new change. Okay, fine. Let's keep it this way. Okay. Next thing which I will do is I will add my Docker file also, because my goal objective right now is to build a container or containerize this application from the GitLab pipeline. Okay. Now I go back again, and this time I'll go ahead and create a Docker file. Okay, cool. Docker file is also created. Now what do I do next? I need to dockerize my file, my application, which is index.html, which is quite simple. Right now, for simplicity's sake, let me remove all this. Let me remove this. And I will modify this, okay, define the job. So in the build stage, I want to do something. I want to dockerize it. So what I do, I will go and do what? I will start writing Docker commands, isn't it? So I'll say docker build -t my static site latest or whatever, and then I'll say docker push, right? I'll say docker push my static site latest. Okay. Now, when I go and commit to change, edit source code, commit change. Let's go back and see what's happening. So the moment I committed a change, it started running a pipeline. I think I will make this light gray so that it's more visible. Okay. Okay. And this time, what happened? If you see, it's failed. It's saying it's failed. It failed because the job under which it was running got failed. So if I go and click on the job to see what happened, I'm seeing the error here. So this is the command which I tried to run, and it's saying Docker command not found. So it failed because saying Docker command not found. Okay. Can anyone tell me the reason behind this? So you have the whole log here. Just try to go through, I'll give you the hint. Just try to go through the log content, what's written here, and tell me what could be the possible reason for this failure. Take few seconds to read it and tell me, or give me some hint.
The Docker repository is not added now.
Can you repeat that?
Docker repository files not added now.
Docker repository files.
Repository files.
Okay. What else?
And sir, it is a user login. Means I means AM login. Then first you also write sudo dockers, right?
Sudo
Root
docker.
angle, root. Use the root account. No? If it is
Okay,
not,
but my error is saying docker command not found. If let's say
सर
it was,
I
yeah.
सर डॉकर बिल्टा -t में डॉट नहीं लगा लास्ट में.
Array, oh, okay. Okay, fine. That's right, but this error is something else. I mean, this was a right problem, but the error is something else. The reason of this is not working is something else.
So, like in Jenkins, we do plugins download particular जैसे Sonar Cube का वैसे Docker का भी plugins is
Okay,
there.
somewhat close, but not entirely there.
And we can also do like in Jenkins, we do the add Sonar URL or like that. In Jenkins, we do specially. So we can do for the Docker also.
But what that plugin does, what plugin क्या करता है? What does it do really?
It will
Dependency.
install dependencies of Docker.
Yes.
Dependencies of Docker. Okay. ठीक है. Let me draw something because this is an important concept. This is an important concept when you build something as well as important when you want to deploy a whole Jenkins or GitLab cluster for your company. Okay. So the way this CI/CD setup works is that you have always two components here, right? If it's Jenkins or if it's GitLab or anything else, it always have these two components. One is something called as master, and other other component can be called as agents, right? Master are the one who has this Jenkins installation and it listens to requests. It hosts Jenkins UI and all those things, or GitLab UI for that matter, etc., etc. And the agents are the individual machines which actually runs the job. Okay, so this is how mostly all the setups of Jenkins as well as GitLab actually works. So agent 1, agent 2, agent 3, it can have n number of agent. So it is agent 3 or whatever. Okay, now imagine there is a pipeline. Okay, and in that pipeline you have a code which requires a JDK, right? So I think the Jenkins, the way you guys have used Jenkins is you used a single node Jenkins. So you have one EC2 instance and you install Jenkins on that EC2 instance, and you were building everything there. There was no other machine, or was there? Did you guys use agents before with the master Jenkins installation?
No, sir. We
No. Okay.
didn't use agents in a Jenkins also.
Fine.
Okay.
ठीक. Okay. So in reality in the actual enterprise setup, you always will have one node which is a master node, and you have many agents there to build your enterprise level company products or projects, right? Now what these agents are called as build machines. This is where the job runs. Job doesn't run on the master node. In your case, if you have used Jenkins, you are always having one EC2 instance and it was acting as a master as well as the agent both, right? But in reality, you have multiple agents available, and these agents have some specialty attached to it. That means if let's say this agent is there and you have a pipeline where you have a Java code which is to be built. For Java code building, if you want to build a Java code, you need a special compiler called as JDK. If you have not heard of it, it's called a Java Development Kit. So JDK is required. It's a software, it's a compiler which is required for a Java code to be converted into a jar or var, whatever packaging you want to choose for Java code. If you don't have JDK on machine, it cannot be converted into jar or var. Okay, so without this you cannot do. Now if the pipeline is there for a Java code, and if you are saying I want to build this, and none of your machines have JDK installed, that means you will not be able to run anything, or you will not be able to not run anything. Let me correct. You will not be able to build that Java code, and you will get Java compiler not found, cannot build. Okay. So to make this work, you need to install certain dependencies, certain things on your agents, and you have to say that I want to run this job, this specific job I want to run on this agent, because this agent has JDK and you know it beforehand. Best thing is you install JDK on all the machines, JDK here, JDK there, JDK there, and that will solve the purpose. So JDK here and JDK here. So it means that irrespective of which agent you choose, JDK is there, and it will build your machine. Sorry, build your source code and convert into your jar file. Okay. The same problem is in GitLab. The same thing is with Docker as well. So when you want to containerize a Docker, how you can containerize? Okay, tell me what is it which you require to containerize a Docker or containerize an application? You need Docker daemon, right? You need the whole Docker daemon thing, which is capable of converting something to a container, right? So that means if you have a GitLab, or if let's say this is a GitLab, if you see, you don't see any agents here, right? There is not a mention of any agent. If you've seen the UI, which we were seeing earlier, there was no agents put there. So this is the next concept, the next generation CI/CD pipelines. This is how they are being set up. पहले old way, what used to happen? एक EC2 instance बनाते थे. You have let's say one EC2 instance which is a master. I'm using the terminology EC2 instance to make you understand that this is an actual machine. It doesn't need to be EC2 instance. It can be very well on-prem machine, but it's a virtual machine basically. It's a machine, physical machine. So one master, I should say, let's say VM machine. I'll not use EC2 terminology. And then you have to link multiple virtual machines with it. Okay, so agent 1, then you have to have agent 2, then you have to have agent 3. Okay, agent 3, and all these machines were actually build machines. Agent 1, agent 2, agent 3 or build machines are actual physical machines, and you have to manage and maintain all of these virtual machines to install necessary dependencies, necessary libraries and software packages like JDK. To build Python, you need to install Python there. For dockerizing or creating Docker containers, you also needed to install Docker daemon on all of these machines, so that when build happens on these machines. So you need to have JDK, you needed to have Docker, you needed to have Python installed, all these things on all the machines, right? And that is a pain, right? Because now you have to maintain so many machines, 50, 20 machines, because in actual actual projects, you have like 50, 60, lot of projects who are continuously building. So you need to have support all those builds. So you may need to have 50, 20, 30, 50 of these virtual machines always available. That means they should be up and running always, because you never know when the build is triggered and when you have to start the build process, right? So this all have to be active at all time, and this is costly, right? You have to have so many virtual machines up and running all the time, which is not good. So what is the solution? So next solution, and that is this solution is available with Jenkins as well as with all the modern tools, GitHub Actions, Gitlab, even Enterprise Jenkins. They all use the same approach. That is, instead of using an hard virtual machine, they now use a Docker virtual machine, a container, which is actually act as a build agent. Because if you remember yesterday we talked about this, because this app or this Docker image is a small virtual machine in itself, right? When this was a VM, if you see, we were talking about a VM here when it was hosted on hypervisor. But this app A, app B, app, they all are Docker container, but they are a very minimum version of the same VM. That means they are still act as a virtual machine because it has OS, and it has all the necessary dependencies and resources to do the job, right? So instead of the new model, the new pattern, which you guys have not used, even though you have used Jenkins, is the new pattern, which is, if I go and make another diagram out of this, so now you have a master node, and then instead of a VM, you have a Docker container. Okay, Docker container and another Docker container and another container. But there's a catch. These Docker container need not be up all the time. And that's the advantage you get. Imagine you have 50 virtual machines to be up and running all the time, because virtual machines cannot be brought up and brought down immediately. But Docker can be brought up and brought down on demand. So what really happen is, in the beginning, there is nothing. Then the moment there is a request of a build request, let's say there is a build request comes, build request for Java project. Okay, let's say the moment this request comes, arrow, let me bring the arrow. This request comes from somewhere, maybe a check-in or maybe a commit event. The moment this happens, the master VM in this case, in the case of, I'm now start using the GitLab terminology. The master here is called as GitLab runner. The GitLab runner listens to it. It says, okay, what do you want to build? You want to build a Java project? Okay. It immediately launches a container, which is a Docker container with JDK already present. Simply JDK, with JDK already there. And this will act as a agent. So this will be your agent. Why it's so small? I don't know why it's so small. Anyway, I'll delete this and I'll put it small thumbnail here. So this act as a agent. So this will be my agent, and it will, everything I need is installed inside it. Okay, this is called as on demand container invocation or agent provisioning. Okay, now you guys tell me which approach is better, this or this. This is approach 1, this is approach 2. Huh? Did you guys understand which one is better and why?
The second
Hello.
one.
The second one, right? Why it is good? I mean, I have already given the answer. I'm just asking you guys to summarize. What's the advantage when you use this approach?
Because this is better off because the master GitLab runner comes up with a Docker which already has JDK, and that is the reason why we can use any project on this, and it doesn't have to be up and running all the time. Docker can
Yes,
be used whenever required. So on demand, we can have this container running.
yes, yes. So guys, this is the industry standard, current, modern CI/CD deployment pattern. This is how most of the companies now build their CI or provision their CI/CD pipe, CI/CD, and infrastructure. Abhi, in current situation, very few companies are there who are using this. When I started, we were doing this a lot, right? So we बहुत सारे virtual machines होते थे हमारे पास, and हम उन virtual machines को maintenance task होता था, and then we used to use different kinds of tools, the chef and all, to provision these virtual machines, put patches there, keep updating the versions of different software we have installed there, and all those things. The huge maintenance havoc was there. A maintenance problems, issues were there. And when with this approach, there is absolutely none. Sorry, I shouldn't say absolute. It comes with a different kind of problems, but the original problems of cost and having to and so much of maintenance of all these virtual machines are completely gone with this approach. So you
Right.
have, sorry.
Exactly, you are right.
Yes. So this is the new approach, and this is what all the tools currently use. That means they provision the agent as and when required based on what it is they need to build. So if let's say it finds that, oh, I need to actually you have to configure that, by the way. So if you say I want to build a Java project, you put an image saying I want to build a Java image, and then it will provision that agent which has the JDK in it, and then it will go and do that. It will go and provision the agent and run it. Now let me go back here after all this explanation. Now you go and see, again go and read and tell me what's happening. Give me a summary of what's happening, because guys, this is what you guys will have to do a lot. That means something is not working, find out why. That the whole IT thing is a puzzle, right? You have to go and solve the puzzles. The better you are at solving puzzles, the better engineer you would become. It's not no one goes there and start writing code from day one and oh blah, 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 code like a kaam complete. It's not that. It's always there is something there, it's not working, by solve it. And to solve it, you always have to go to see the logs, make sense out of the logs, try something and then check what's happening, and then try something else and see what's happening, then compare the results. It's always hit and trial, and solving the, very similar to how we solve a puzzle. So now you guys tell me what's wrong. अच्छा, okay, tell me.
सर CI ये CI रिपोजिटरी में उसको लिंक नहीं है, इसके वजह से शायद एरर।
It says empty Git repository. Is that?
Not really. अच्छा ये बताओ, what is the agent which it has triggered? मैंने अभी आप पूरा लॉजिक बताया, right? I showed you all, पूरा ये बताया लॉजिक इसका. तो जब मैंने रन किया तो there was no agent, right? Because अभी तो कोई VM ऐसा है ही नहीं मेरे पास, right? So you guys see and tell me what type of agent it has used. It's written right there. What agent it has used?
Ruby?
It has used this agent, right? So by default, if there is no image mentioned, then Gitlab will always use a default image, something written in config.toml file, which is an internal Gitlab file. Don't worry about it. That's where it's mentioned. If there is no agent mentioned by the user, use Ruby tagged as 3.1 as a default image and run the job in it. Okay. Now what really happened now is a new agent was created, something like this, right? So it has created a new agent which had an operating system, Linux operating system, but the compiler we had there was of Ruby only. So only Ruby related code can be built with this approach, right? What's wrong? We are not even trying anything with Java. We are trying to have Docker. We are trying to run a Docker command. And it's quite evident why it didn't work. Why? Because it's a simple Ruby Docker container. It's a machine. It's an agent machine which has two things, operating system and Ruby compiler system. That's it. It doesn't have any Docker installed inside. Right? And that's the reason I'm getting Docker command not found, because to run a Docker command, if you remember yesterday, what did I tell you with the Docker thing? Docker had three components, right? Docker client and Docker daemon. So when you say something like Docker build, that means you are using a Docker client. So neither Docker client is installed there and neither Docker daemon is installed there. अगर वो Docker client install भी कर लोगे, but there is no Docker daemon, no Docker backend process installed there, which can help you build the image, because Docker daemon is the thing which builds the image for you, right? So inside of this image, जो अभी हमने use किया, which we have just seen there, there is nothing except a OS plus a Ruby compiler. So when I said run this, what happened? Master runner ने repository को उठाया, उसको checkout किया, git checkout किया, कहाँ किया? Here, inside this container, did git checkout, and then on that code it tried running docker build. अब इस machine के अंदर docker है ही नहीं, so you will always get this kind of error. Okay, how do we solve this, right? Now, what I was telling yesterday was also this. This is a dockerized pipeline. This is something. Okay, इसको क्या कहते हैं, right? We call this as a dockerized pipeline. My pipeline is dockerized. आपका पूरा Docker infrastructure is a Docker infrastructure. Dockerized CI/CD pipeline infra. This is what you can call this to refer कि ये क्या है. Okay, this is easy, right? This is easy. यहाँ सब में machine में install करो and that's it. जो आपने EC2 instances में भी किया था, which where you have just one EC2 instance, and inside one EC2 instance you deployed everything, and then it has all the things to run or build the software. So उसमें आपने Docker भी install कर दिया, JDK भी install कर दिया, तो उसको कोई problem ही नहीं होगा. But this is not the case here, right? Because then you have to really define what you need and when you need it, so that your agent finds it. So your pipeline is a Dockerized CI/CD pipeline infrastructure. Now to solve this problem, you need to have a unique solution which is there in GitLab. It's not only in GitLab, it is actually Docker solution. It's called as Docker in Docker, which is very simple thing. Let me show you a quick diagram. So you have a machine, and inside this machine, you have installed a Docker container, and this machine is not also a machine. This is a Docker container itself. So you have a Docker container. Oops, sorry. So you have a Docker container. This is a Docker container, and inside this you have a Docker daemon, and inside this you also have a Docker client. You also have a Docker client. So now with this container, if you run, so instead of imagine, ये इससे अच्छा अगर मैं somehow ये provision कर देता run time पे, if I would have done this, wouldn't it be better? Because now इसके अंदर I could have executed my Docker command, right? I could have said Docker build very easily. I would have said Docker build -t whatever dot, right? If I would have said it from inside the container, यहाँ पे इसको Docker client मिल जाता, and then Docker client would have executed with Docker daemon. Docker daemon would go and create it, and then my build Docker command would get executed properly, right? So for my specialized case at the moment, I need this kind of setup. This thing is what I need. So I need a Docker in Docker, also called as Docker in Docker, also called as DIND. Okay. Now Docker in Docker is a specialized image given to us by whom? Docker itself. Because the Docker in Docker, let me show you that. Docker in Docker, Docker official image. So in the Docker hub, you will find this Docker in Docker image. Okay. And what is Docker in Docker? Although running Docker inside Docker is generally not recommended, they do not recommend this, but there are still some legitimate use cases such as development of Docker itself. Docker is an open source and automates the deployment application, blah, blah, blah. So it is an official image given to you by Docker, but they say it's not recommended because Docker in Docker requires some extra high root access privileges, which is a security risk. And that's the reason they say don't use it. And at the same time, it's not fast. It's a bit slow. And when you have to build 3-4 projects in a day, In an hour, it's okay, but when you have to build hundreds of projects per hour, this approach has a performance problem, performance stall, right? So it's not recommended. I'm just telling you for the sake of understanding that this is one of the solution, but there is also a better way called as Google Canico, which also I will show you in a while. Okay, but right now we'll only talk about Docker in Docker, how we can use Docker in Docker in GitLab to do or to build our Docker image. Fine, let's do it very quickly. So now I go back here and let me also Google it to you to show you Docker in Docker GitLab. So GitLab has a very good documentation available where whenever when you're using GitLab and you're stuck, its documentation comes very handy and it has really explained things very nicely there. So they're saying use Docker to Docker build images. You can use GitLab CI/CD with Docker to create Docker images. It's explaining exactly what I was telling you earlier. Okay, there are Docker alternatives. There are different ways of building it. The different Docker alternatives they're given here, and one of the way alternative is Canico, which I will explain later. And there's one more called as Builda, but we'll not go through that. But we'll only, for now, focus on Canico. Only Canico is what we'll do. This is it's a Google utility and very widely used for such use cases which we are experiencing right now. So let's start with Docker in Docker, right? So this is exactly what I explained to you, right? Docker in Docker. So what you do, how you do it, Docker in Docker, which is DIND, how do you use this? To do that, you have to put in two things in your source code, or not source code, in your GitLab.yaml file. That is, you need to mention what image I require, and then you also have to say something like services. So these two things is what you need to put in your code so that your code works. And when I say code, it is a GitLab YAML file. So in the top of it, I will simply say, because if you see, it was automatically using Ruby earlier, right? अब मुझे Ruby नहीं use करना है. Okay, I want to use a Docker in Docker image. I don't want this. I want this. Because inside this, I will have Docker client, I will have Docker daemon, and then it can run my Docker commands and build my application. This is exactly what I want. So now instead of saying nothing, I'm saying image Docker, and I'm saying services as Docker 201016 DIND. This is again an official image which is coming from Docker side itself, which is Docker Hub. Fine. Before I go and run this code, anyone has a question? Okay.
हेलो
I have added. Yes, go on.
सर मैं थोड़ा स्टार्टिंग में लॉस्ट हो गया था, तो ये आप कौन से ये जो टर्मिनल है आपका,
ये
हाँ,
हाँ
ये कौन से टर्मिनल में आप वर्क कर रहे हैं, मतलब ये थोड़ा मेरा लॉस्ट हो
ओके, ये GitLab का ही एक टर्मिनल है which is you can modify the whole GitLab repository from browser itself, and to access this you go to repository and you click on edit and you say web IDE.
Okay. You are working GitLab terminal, okay?
I'm working in GitLab IDE.
IDE. Okay.
Integrated development environment of GitLab is what I'm using.
Okay. So then means we can download a Docker here.
No, you're not doing anything. GitLab is doing it for you, no? You are only configuring what you want. So
GitLab is not like GitHub.
it is like GitHub. It is exactly like GitHub.
It is repository or any other thing.
It has all the things which you have in GitHub. So GitHub also have two things. GitHub has a repository and GitHub also have a CI/CD engine. And GitLab also have a repository system, Git repository system, but it also have a CI/CD engine.
Okay, sir.
If you compare this with Jenkins only have CI/CD engine. It doesn't have a repository. So how you make use of it? आप अपने कोड को GitHub में रखते हो और Jenkins में उसको check out करते हो, right? So there are two parts. Source code lives in GitHub or GitLab, and Jenkins can be your CI/CD engine. In my case, right now, GitLab has both the things. That is, it has repository system. This is how repository system looks like under code, but it also have the CI/CD engine. So all the things which you can do directly from here.
Okay, sir. Okay.
Okay, and it failed as well. Okay, good. It did not fail really. Okay, you see it worked. So remember previously, instead of here, we were seeing what? We were seeing Docker image, Ruby or something. It was downloading the Ruby and running my things in
Yes,
Ruby.
right.
Now it is running this in Docker dint, Docker 2016 dint. And there it is doing everything, Docker pull, blah, blah, blah. And then it did come execute the command Docker build. It did execute it, this command. Because in this specific container, I have Docker client and I have Docker daemon. So whatever I run inside this, that will get executed automatically because I have everything what I need. Okay, so when I say build request for Java project, master GitLab runner saw which container or which agent image I need. It found I need Docker dint agent image. Fine. It went back and created this container for me. From that image, it created the container. This container wasn't there before and it is gone now. It was only there until the job was running. When the job started running, the image got converted into container, and then the code got checked out inside, and then Docker executed. Docker commands were executed, and then it built it. So the Docker build succeeded. What did not work? So you see, it succeeded. What did not work was the push. The push did not work because I was trying to push it onto the docker.io, where I don't have the necessary permission from this agent. When I do Docker push from my local, it works because I already have credentials saved there. But here I don't have, so it will not directly do that. So I have to do some sort of login first, Docker login username, Docker login password, and only then it will work. Okay, that's cool. So instead of fixing this, okay, any questions so far?
No, sir.
Okay.
No.
Yes, go on.
सर जैसे कि अगर ये प्रोजेक्ट अपना अभी फॉल जेडीके में मतलब जावा में चल रहा है, राइट?
हाँ,
और एक प्रोजेक्ट में ऐसा तो नहीं होता ना, कभी जावा भी होता है, कभी और अदर लैंग्वेज भी यूज होती है, राइट?
यस।
तो फिर इनके लिए सबके लिए एक सॉल्यूशन हो सकता है कि जैसे कि अब अगर मैंने एक जावा में किया और सेकंड मेरा इसमें है, अपने स्क्रिप्टिंग इसमें है सी प्लस में फॉर एग्जांपल, तो फिर सी प्लस के भी इसमें इंस्टॉल करना पड़ेगा ना, मतलब जो भी लैंग्वेज में बनाऊं?
Right.
हाँ,
So good question. So it's different. So for example, I
हाँ,
defined this at the top, right? I don't have to do
हाँ,
that. I can just define it here at the job level. Okay. Now I want to have something which will build my Java code, right? So I will say build Java, and I'll say stage as build, and then the image I would use now as an agent is JDK something 123 or whatever version we have there. Okay, and then in script, then I can run my commands like I can say maven clean install or maven clean deploy or something, and this will build my Java image.
okay.
Okay, so you can define images at the job level, and based on किस job में आप क्या build कर रहे हो, you can define that image directly there.
Okay, sir.
Okay, so there are these kind. I mean, the concept it always remains the same. What you need is what you need to define first in your GitLab. If you think this job require a Java compiler, then you will use that image. You will say JDK. If you think it will require my Python compiler, then you will say Python. Okay, something like that.
एक कंटेनर मतलब एक ही इसमें मल्टीपल लैंग्वेजेस यूज हो सकते हैं ना?
क्यों नहीं हो सकते हैं. But
Okay.
mostly you will not get such images which has everything. Right, so if I want to build my Java, then it will have a JDK images available. right? So I will have these kind of images. I will have to use JDK images. Okay, so it depends what is your use case, and it can be configured, and everything is to be configured is always from here. So मैं एक example देता हूँ. Let me show you a Python example. Okay. So this is my Python example. I have a Docker file here, which is there. Okay. अब इस case में, even though this is a Python program, I don't have to use a Python specific image. Why? Because I am using a container, so my Docker file will do all the things for me inside. So I will not be using any image which has Python there, because I'm dockerizing it, right? So all I need is Docker dind, anything which can manipulate or it understand my Docker. I don't have to mention anything specific to Python in my GitLab YAML file, because I'm abstracting all of that inside my Docker file. Because inside I'm doing, installing my Python, and then installing all the dependencies, the requirements, all the libraries, etc., and then I'm running it, right? So I don't need any Python specific library in my GitLab YAML file. Basically, this is what I'm trying to explain. So you only need you only need language specific images if you are doing something language specific there. Then you have to define those images here. But if you are using Docker technology, then I think you don't need to, because then Docker file contains all those things. So you don't really have to mention it in your GitLab.yaml file. And let's say if you're not using Docker file, then why not? Then you define different jobs like this. कि मेरे ये image में ये JDK है, next image you have this .NET, and next image you need Python. But it is a bad practice to have all that in a single repository. You should always segregate it. But still, if you have such cases, a monorepo sort of thing, then you can still use different images to build different packages in your GitHub or GitLab repository.
तो ये सारी इमेजेस के लिए ऑटोमेटिकली मतलब डिफरेंट कंटेनर्स बनाएगा ना?
Yes, depending on आपने क्या mention किया. If you are so okay, originally it was mentioned at the top like this. Okay, but here in this case you are saying I need for this job, I need this specific image, then it will create this image for this when it runs this job. And for rest it will use this. Clear?
Yes, sir.
Yes, sir.
Okay, fair enough. So this is how basically this GitLab YAML file works, and this is how Dockerized pipelines work. You define what image you need, and it will use that image to build that thing. Okay, next we have a bit less time now. I've spent too much time, I think, explaining this. I'm not sure if it's worth it to explain this slow, but I thought it's a new topic, so I went very, very slow. Now, very quickly, I will show the next way of doing this. So one way is using Docker, right? Let's see the next different approach of how we do this. So you remember I showed you the way how Docker Canico can be used here. So in Docker Canico, it's very, very simple. In Docker Canico, if you want to use Docker Canico to build it, there is special code snippet which you have to put there. Let me go click this. So you don't have to use any Docker dind image to make this work. All you need to do is to, let me copy this and I will paste it here very quickly. I'll not do Docker push for now. Let me remove this, or maybe let's keep this. Let me remove this. Okay, stage is this, and then I will say build with Canico and build with dind. Okay, and I will move this from here and I will place it inside so that you know that this is only for being used for inside this container, or sorry, this job. So this is the job which is built with the DIND. In this, I'm using the DIND approach, Docker and Docker approach, to build my website, so build my Docker container, sorry. And then another one is build with Canico, and here I'm attaching this with the same stage. But he's using a different image here called as GCR, Google Container Repository or Registry.io Canico project, and this is the name of the container or image, which is a very special image. That means you have to pass certain things, certain arguments, and then it will create the Docker container or Docker image for you. Instead of this, I'm simply go and write the latest. So what I'm doing here, I'm saying this is the image I want to use, and I want to run a script. Under script, I want to say Canico executor, and then I want to pass 3 arguments. I'm saying context. So context is what context is required to create the image. So I'm saying dot here, right? So context means I want to pass all the lines, all the files to the Canico container. And then what is it? Where's the Docker file? So I'm saying this is my Docker file. And then where I want to push it, I'm saying push it to CI registry image. This is a default variable in GitLab. That means GitLab also comes with its own registry system, and it will go and save it there. Okay, and I think I've already tried it once with latest. This time I will say version 2, whatever. Okay, and then save. And now let's run it. Edit Canico. Let's go back quickly. Okay, sorry, my static site. Oh, this was a separate project, so it's okay. Pipelines. Failed, invalid YAMLs. My YAML is invalid. Why? I think that's why. What else is wrong? Okay. Services, images. So if you know how YAML works, it is very indentation based, and it complains when you are doing wrong indentation. If you don't know YAML, I would post a link. Just go through it, and then you will learn. You will know it. It's not that difficult. Corrected. Correct YAML. If your YAML is invalid, we'll say YAML invalid here, just in case. So now both the jobs are running in parallel. You know why they're running in parallel? I explained this in the beginning, because both this job as well as this job is linked to stage build. Stage build. Build is the first stage, and that's why it's running together. Okay, and now you see Docker with Canico is completed already, and Docker with Dind is still running. So you see, you can notice the performance of both the approaches just by looking here. Okay, if I go to Docker, sorry, build with Canico, it has not only built, it has also pushed. You see, it has built as well as pushed. Where did it push it? It pushed it into the registry.gitlab.com, Akash Lab, my experiments, Z my something v2. Where it is located, if I go to deploy, I go to container registry, I would see the image here. So it did not go to Docker Hub, it went to my GitLab registry. So see, now you see the power of GitLab. It has Git, that means you can save your source code. It has CI/CD engine. It also have package registry. It also have container registry, which Jenkins doesn't have, right? Jenkins is just a CI/CD engine. Okay, so that's why people have started moving towards these modern tools, because they are the consolidated version of all the CI/CD tool chain which you would ever need for your CI/CD jobs. Okay, very quickly, I will go ahead and make a small change. So I will go here and I will, let's say, add a span. I will say, wow, this is a super good change. So now I'm showing you the power of CI, continuous integration. So now I'm a developer. I went ahead, I made a change somewhere here, and then I'm saying I want to publish this, right? So I will go ahead and click on added a new change, commit to new. Okay, now my pipeline will start running automatically. Where's my pipeline? Go, okay, build pipelines. Already built and pushed. Okay, I think it may have overwritten the previous image because I did not change the version. Doesn't matter. I'll go back to my container registry and I will go and say copy the path, and then I will try to run this on my local. So I will simply open it, clear, I come here, and then I'd say Docker run, my alarm rang. I have to log off now, but very quickly let me show you this. IT name, my static site, this was a supposed to be deleted version, and then I'm saying port 8087, let's say 80, and here I must say v2 because it was supposed to be v2. So it's saying unable to find image locally. It will start pulling it from this repository, which is this one. And if I go ahead and run localhost 8089, boom, didn't work. What happened? It was 8089 or 87. It was supposed to be 87. So it worked, right? So this is the, if you remember, this is the change I made here. This is super good change, and I'm getting this here. So you see my continuous integration is working using my CI/CD pipeline. The moment I say make a change, the pipeline executed and it has pushed the container somewhere so that anyone then now can use it. And when I say anyone, it is in this case right now me, but eventually it's going to be a Kubernetes cluster which is going to be which my pipeline is going to be deploying directly to my cluster or directly to my host, and that's called as deployments, continuous deployment. All right, I am towards the end, guys. I had to log off early today. I'm so sorry. This is the extent of what I could tell you guys today. Any questions so far with the approaches which we have taken?
No, sir.
Okay, so the lesson learned today is GitLab and the Canico. So Canico and GitLab is what you have to use, and Canico is not something which you can use here. You can use it from your local machine also. However,
We have to install the Canico on local machine, sir?
No, this is the image now. You don't have to install
Okay.
anything. It can run on a Docker
Yeah.
daemon or on local Docker. मतलब it doesn't make sense on local because local तो आपके पास already Docker daemon है ना. So why you would need
Yeah.
Docker Canico? Docker Canico is to be used at places where you don't have access to Docker daemon. You don't have a Docker installation. When you don't have a Docker installation, how will you then run it? In this case, यही तो problem थी ना. In this case, in this pipeline, if I comment this out, that means there is no Docker available here. There is no Docker daemon available here. But we need to build a Docker image, and that's why you need something which can build Docker image from a Docker file. And that's why you have to use something called as Docker Canico, which is a Google open source project provided to you by Google. And that's what we are using.
Okay.
सर हम लोग जेंकिंस नहीं पढ़ेंगे क्या?
हम लोग सब नहीं पढ़ सकते ना विनय. We can only do one thing and one thing only for each
requirement
tool.
नहीं पड़ेगी ना, GitLab वगैरह यूज कर रहे हैं तो basically ना.
If you have
GitLab पे
yeah, so if you have GitLab, then that's what we are going to use. Jenkins we will not. बिकॉज जेंकिंस सेटअप में बहुत टाइम जाएगा, आप लोगों का भी और मेरा भी, हमारे पास उतना टाइम नहीं है, बिकॉज जेंकिंस में यू हैव टू इंस्टॉल जेंकिंस, एंड जेंकिंस एक सिस्टम में चला के आपने चला के देख लिया, इट्स नॉट मच, यू हैव टू एक्सपीरियंस दिस पार्ट। ओके, कि आपको वो एजेंट्स अटैच करके देखना है उससे, सो आई थिंक आई डोंट हैव दैट मच टाइम, आई हार्डली हैव 2 months 3 months एंड वी हैव टू रियली कवर लॉट ऑफ थिंग्स, so I will rather spend more time in advanced and modern things rather on Jenkins.
सर
Yes.
ये CI/CD के लिए ऐसा मैंडेटरी नहीं रहता ना कि आप जैंकिंग ही यूज करो या फिर गिटलैब ही यूज करो, किसी ने भी कर सकता है?
यार देखो, डिफॉल्ट टूल चेन होता है, जब जॉब इंटरव्यू आता है ना, तो वहां पे लिखते तो हैं वो लोग कि जेंकिंस गिटलैब, राइट?
ओके।
अब इनमें से कोई
हाँ।
एक आता है तो फाइन है, बट doesn't if you are interested in Jenkins, let's say imagine करो अभी जॉब ओपनिंग आया, उसमें उन्होंने बोला जेंकिंस भी थोड़ा आना चाहिए, तो फिर Jenkins not that difficult to know, right? You can just quickly put a EC2 install किया लोकल पे, देख लिया Jenkins के syntax. But what we need is an end-to-end setup. हम क्या कोशिश कर रहे हैं ना, हम कोशिश कर रहे हैं end-to-end setup करने की, जहाँ पे हमारा पाइपलाइन पूरी हो और वो end तक डिप्लॉय कर सके towards the Kubernetes cluster, right? अब अगर हम Jenkins
Okay.
यूज करेंगे तो वो उसका जो सेटअप है, इंफ्रास्ट्रक्चर सेटअप, it can create lot of problems for me as well as you. उसमें challenges आएंगे, ये फंसेंगे, हम वहां फंसेंगे, and हम वहां फंस गए तो then time will extend, and I have to end these sessions in next 2-3 months. I cannot go beyond it. So I'm
Okay.
teaching you a tool which is very acceptable, industry standard, modern tool, which has wide acceptance these days.
Right, which is necessary.
Okay.
Yes. So I don't think you will lose anything if you do GitLab rather than Jenkins. But you know, we have to choose our battles, you guys. In a war, let's say we are in a war-like situation and you have, you know, a lot of battles to fight. You have to choose. And it's the choice which will make you win the war, not like all battles. You cannot win all battles. You cannot learn everything. You have to choose what's make more sense. You have to choose what makes more sense, what is easy to use, what will give you faster results, and just do that first. And that's why I'm saying don't go after each and every tool. Just see what is easier and just learn that so that your concepts around it is clear. Okay, so for example, we need to do a lot of concepts around CI/CD pipeline in terms of stages. So we need to do all these things, right? We need to do container scanning, we need to do SAST, code coverage, and all those things. This does not come out of the box from Jenkins. Then you have to configure Sonar, right? And then for Docker scanning, you need to configure Trivy. So then it will keep on adding more and more tool chain into what you need to learn. But if you use GitLab, they all are out of the box. So now if you use GitLab, under the hood, they do use all these tools behind the scene, but it's abstracted from you. So you get to see the implementation of these stages and how the things work, but you don't have to bog down into the nitty-gritties of or the underlying technical complications around it. So that way you can go through it quite fast and thereby also understanding the underlying idea of those concepts. I'm not sure if I'm making sense right now, but this is basically the reason we are using GitLab is it is a modern tool which a lot of out of the box features, and it will make your journey faster towards where you want to reach. That's my opinion on it, by the way. Other than that, Jenkins is a wonderful tool. I spent more than 10 years in Jenkins and I still love it. There's nothing wrong with Jenkins. It's just when it comes to learning it, I think you already tried using it a few times back. A few of you actually have tried this, but it will have a lot of complications setting it up to the right standard which we want. So to set this, for example, ये जो मैं अभी बता रहा था आप लोग को Docker concepts here, वो Jenkins में सेट करने जाओगे तो it will take a month for you really for me to tell you, and वो मैं बता दूंगा फट से एक बार करके, फिर then you guys also have to do it, then you will not be able to do it, वो आप stuck हो जाओगे वहाँ पे. We don't want, we want to go fast. इसलिए हम वो नहीं कर रहे हैं. वो those concepts is very hard to demonstrate in Jenkins side because it's just open source and doesn't have a lot of things out of the box. Okay, what else?
सर एक तरह क्वेश्चन है.
हाँ
हेलो।
हाँ,
तो
बोलो बोलो।
ये मतलब जैसे ये गिटलैब जब हम यूज कर रहे हैं तो मतलब हमारा जो काम रहेगा, जो कोड लिख रहा है उसका कोड इसमें मतलब गिटलैब में एग्जीक्यूट हो रहा है नहीं, उसको चेक करना है ना, मतलब कि कोड लिखना भी अपने को।
कौन सा कोड? मतलब देखो, कोड यहाँ पे,
ये जो
ये तो आपको ही लिखना
हाँ
है, ये तो आपका काम है। आपका
मतलब
काम ये नहीं है। दिस इज नॉट योर
ओके
योर जॉब। योर जॉब इज gitlab.ci.yaml।
ओके, मतलब वो जो एरर उसको आया है, जो अभी आपने देखा था, जो एरर दिखा रहा था, वो एरर को अपने को फाइंड आउट करना है ना, मतलब कि वो एरर नहीं
यस यस, वो आपका काम है। पाइपलाइन का काम आपका काम है।
आया। ओके ओके
Okay, so for example, if I show you a more complicated example, let's say this application. Huh?
ओके
In this application, I have lot many things here. You see, so appointments
यस
API is an API. This is a Spring Boot API. If I just quickly show you, or I can show you from web IDE. So this is the project. This project has a front end and a back end. There are 3 APIs in this project: source, Java, advise, controller. This is all this is an API basically, Spring Boot REST API. ये developer बनाएगा. This is not your job.
ओके
Okay, Doctor API, developer job. Patient API, developer job. View, UI, Cypress, and all those things, developer job. What is your job is perhaps help developer in writing good Docker files. So this is a Java Docker file to build Java project. Okay, you can help that guy to create this good, and then GitLab CI/YAML file is also your job. Okay, so here if you see also I'm using Docker DND.
मीन मुझे मशीन में वो चीजें मतलब सॉफ्टवेयर उनको देना है इंस्टॉल करके कि ये इसको सपोर्टेबल सॉफ्टवेयर क्या
क्या देना है?
है, मीन्स जैसे कुछ जैसे दो क्या हाँ मतलब ये ध्यान नहीं
सॉरी, मैं नहीं समझ पाया क्वेश्चन क्या।
मीन्स जो जावा जैसे जावा बिल्ड का जो एरर आ रहा है, मतलब जो यमल वगैरह इसमें नहीं है, तो वो इंस्टॉल मतलब इसमें कोड लिख के देना है ना उसको।
यार कुछ देना किसी को नहीं है, राइट? दिस इज द पाइपलाइन, दिस इज एवरीवन इज ऑन द सेम पाइपलाइन, राइट? एंड योर जॉब इज टू बिल्ड द पाइपलाइन सो दैट द सॉफ्टवेयर गोज फ्रॉम पॉइंट ए टू पॉइंट बी। दैट्स योर जॉब। उसके लिए हाउ यू विल डू इट, you will most of the time you will spend your time in gitlab.ci.yaml to create the pipeline and to insert the right stages inside so that it builds. So this is primarily is what you would do. Okay, the same goes with Jenkins, right? When you have Jenkins, what you do, you write Jenkins file, right? So you create Jenkins file, insert right stages and then things, and then if it doesn't work, then you have to solve the problems yourself. And if you think the problem is coming from the source code, then you will involve developers also. Ask them why I'm getting this error. Do you know why? And then you can collaborate together, and this is how it works.
ओके, अरे एक फ्रेंड सपोज डेवलपर ने जिस कोड लिखा है उसको उसने एग्जीक्यूट करा पर वो एग्जीक्यूट नहीं हुआ, तो उसके अंदर क्या क्या चीजें मतलब वो पाइपलाइन में मिस्टेक है, तो वो मतलब पाइपलाइन को उसको लिंक करना रहेगा, मतलब वो पाइप
If pipeline is failing, it's everyone's responsibility. So you will go and see what is the error. Developer will also go and see what's the error. If there is an error which developer can fix, he will fix it. If it's error, then you can fix, you fix it. So error can be anything, right? Error can be application specific error, error can be pipeline specific error can be anything. So you should know what is the error is all about. That's the reason I told you guys API. I am supposed to tell you how API also work, because if you don't understand the source code, how will you find whether this error is mine or this error is a developer's error?
Okay.
Right. So error can be anything, and then you are the first person. The first line of defense is you, that you will go ahead and see and solve the error first. And if you can't solve it, then you start involving more people. If you don't understand what's happening, then you start involving more people. So that's the process. That's how the process goes.
ओके
सर
Okay.
सर कल आपने डॉकर का टर्मिनल ओपन किया था, राइट?
मैंने डॉकर का टर्मिनल नहीं ओपन किया था, मैंने अपने सिस्टम पे टर्मिनल ओपन किया था. देयर इज नो डॉकर टर्मिनल.
सिस्टम पे आपने शायद डॉकर डाउनलोड किया था.
सिस्टम पे डॉकर डेस्कटॉप डाउनलोड किया था मैंने. यस
यस, है ना, और उस पर आपने वर्क किया था. आज आपने गिटलैब पे किया.
यस.
तो सर ये गिटलैब का जो है ना, जैसे आपने आज उस पे वर्क सीधे शुरू कर दिया तो एकदम से सारी चीजें समझ नहीं आ रही थी उसमें,
हाँ
क्योंकि हम उससे फेमिलियर नहीं है ना सर.
तो समझ में तो नहीं आएगी यार. देख जो भी मैं बताऊंगा यू विल नॉट गेट इट इन द फर्स्ट डे. So you will have to practice. The reason I'm telling you is that you will go back and watch the video again and see the code which I have written and try it. So the more you try it, then it will start making sense to you. It will not come
सर
at day
गिटलैब
one.
हमको अलग से फिर पढ़ना पड़ेगा अभी, मतलब जैसे गिटलैब का हमको जो इंट्रोडक्शन वगैरह है कि किस तरीके से क्या क्या काम वर्क करता है, कैसे होता है इसके अंदर,
Yes.
तब जाके आपका लेक्चर हमें जाएगा.
So मैंने last week बोला था ना कि पढ़ो इसको.
Yes.
I sent a link also last
Yes.
week.
और
So
सर जैसे ये गिटलैब है, उसके बाद जेंकिंस अगर हमको पढ़ना है तो हम पढ़ सकते हैं ना?
No, who's stopping you? Why not? पढ़ना ही चाहिए.
तो
इसी
सर जैसे इसमें अगर कुछ
हाँ.
प्रॉब्लम आती है, हम मैसेज करेंगे तो फिर थोड़ा उसमें सॉल्यूशन अगर आपको कुछ समझ आता है तो आप बता दीजिए.
देख भाई, if you post a question and if I can solve it then and there I will solve it, but it doesn't happen that way. If you post a question, मेरे को ये error आ रहा है. If I see this error, maybe I cannot solve it by seeing it. So I have to get involved and see what happened, and that much time I don't have. So ऐसा expect मत करो विनय that I jump into a call with you and we both together solve it. I don't have that much time.
ओके सर.
Okay, so
जैसा पिछली बार कुबरनेट्स मैंने यूज किया, उसमें मुझे प्रॉब्लम आया. मैं अभी उसके लिए रुका हुआ हूँ. आप जब पढ़ाएंगे तब वो प्रॉब्लम मैं सॉल्व मतलब
so see, we have to adjust to the situation. In this batch, we have three kinds of people: people who are advanced, people who are in middle, people who have just no clue.
Right, sir.
Right? So we cannot jump leaps. कि मैं ये भी बता दूं फिर एक दिन Kubernetes बता रहा हूँ, एक दिन मैं कुछ और बता रहा हूँ. I cannot do that. So I have to go in sequence. So the people
Yes, sir.
who know a lot of things have patience. People few things, you also have patience. And people who have no idea, please try to catch up fast.
Sure, sir.
Okay, so we have to be accommodative of all the different category of people we have here. Okay, so we have to go in sequence, and this is the right sequence. I think this is the best I can do to cover or to cater to all these three groups.
Yes, sir.
Okay, cool guys, I have to drop off now. We see you next time. I'll post all these things after some time. I cannot do it immediately. I have to go somewhere. So next 1 or 2 hours, I will publish the video and all. And then I will post some links for you to go through them. And I will also post what we cover next session. I haven't planned it yet. And as I said, I have to first prepare myself, and then I will come and teach you guys. So I have to do a preparatory work beforehand. So let's see what I can cover next session. But I think I will try to go through the CI/CD pipeline itself. There are a lot of things which you have to do inside. You remember we have different stages. So I will put more stages inside, some SAST and different kind of things. And we try to do a deployment as well. So we have to reach towards a continuous deployment stage. So we'll see where we can deploy first. Maybe we can deploy something in the Beanstalk, Elastic, अपना AWS Beanstalk, and then we'll see how we can do it in the Kubernetes. But that's for later. All right. Thanks everyone. Bye.
Thank you so much.
Thank you, sir.